Thank you, Admin. Okay, so the topic of this year's and last year's Architecture Summit, AI. So, I mean, the name of our topic is exploring the boundaries of LLM reasoning, but I mean, it's not like we gave a SAT exam to the LLM. We wanted to actually like use it this year. Last year, I gave you a very theoretical speech. This year, I'm going to give you a much worse technical speech. I obviously am tired of doing this, so I want to, like, you know, do something badly. Let me just close this window here. Okay. So I have been given the honor of introducing the team. I worked on this together with Mersim, Aldo, Softic, and Ivan. And we are going to quickly go through the project summary, show you tools that we have learned and used during this entire process. I'll give you a short demo. I'll also give you a recording of the demo in case the LLM is stupid. And we'll open up the floor for questions, answers, not just to myself, but the other four guys who have also. Okay. Look at that. So what was our goal? We want to see how will the LLM reason if we give it basically some tools and have it understand a complex input and perform a series of steps. So basically, to make it more concrete, we want to see, could it explore an API spec to find the API calls it needs to make? Can it chain together different requests? And can it understand if the request we're asking it to do, is it unfeasible? And can it maybe resolve that unfeasibility by using some of the tools you give to the LLM? So to make this more concrete, what we did, it's off. We chose to like answer these questions for ourselves by building a simple event management system where the LLM will get an open API spec of some API and then be able to use that API to fulfill a series of queries and maybe even expand the API if it needs to do that by using tools that we have given it. So we use this headless CMS to create, manage, and show the Open API spec, and a bunch of tools that are right now standard for LLM-based applications and workflows. Okay, this starts working. So the tools that we use are Tachyon, LangChain, Strapi, and Streamlit. I'm going to get into each one of these in more details in a second. But small intro, we have never used these before. Most of the team never used Python, so we really had a beautiful opportunity to experience white spaces issues instead of issues with the unclosed brackets. So that was a learning experience for all of us. So when we started working on this, first we were, hey, we need to do this in Azure DevOps. We need to create the tasks, tickets, and there's 5 of us. We're very busy, very lazy. So we found this tool called Tachyon. It's a assistant that helps you write out all of the tickets and stories in Azure DevOps. So you give it a prompt, and it really saves you time. It's even got some really creative ways of filling out what you needed. And most importantly of all, every ticket it writes, it's really readable. So, correct grammar, correct formatting, and based on your input, it can create everything up from, the epic, the feature request, user stories, even down to the test cases for the stories that it has written.
So, what about you guys? You added it to our DevOps. I saw it. I want to use it, but we stay with it for it's not about me.
We can enable it. You need to use your own GPT subscription. That's why we turned it off. We don't want to be paying for everyone. So really useful tool. And we use the LangChain framework now. As we found out while working on this, LangChain is literally the de facto framework for working on LLMs, even though it was published in November last year. So it really, really simplifies development of agents, of agent chains, of any LLM-based application. We were shocked just how easy it is to create an application that interacts with an LLM. It's very modular. It's basically plug and play. And since it's become somehow the de facto standard, there's a ton of plugins for it. So if you want to have an LLM that's going to browse Wikipedia, use any external tools, there's already probably a plugin for it. So it's really, really useful. And it's completely use case agnostic. It's open source. You can use it, play around with it, see what other people have built. The SDK is available in Python and JavaScript. We use Python, and it also has got a bunch of other like projects built on top of it, like LangSmith, and they also have this upsell where they help you like deploy an entire application, but we didn't use it. I think we already know how to do that. So basically, after having zero experience with all of this, now we have a lot of experience, and this time next year we're going to be millionaires when we kind of have an idea that we can actually monetize using these LLMs. So I keep on pressing the wrong button. Okay. Oh, here we go. So agents, what are they? An LLM is stupid. If you give it a question, it gives you an answer. But all of its knowledge is stored somewhere inside of these embeddings, inside of this database, and it's stored up to a point. If you ask it, what day is it today? It's not going to say. Instead, it might give you like a Python function, hey, run this to get today's date, because it exists in isolation. Now, if you want to give steroids to the LLM, you need to create an agent. What is an agent? You can, you can basically tell the LLM, hey, you are tasked with doing this, and that's going to be this LLM's entire purpose in life, and you can also provide it with tools. So basically, the agent is then the LLM that's been provided a bunch of tools that it can use, so you're not constrained with just doing this chatbot experience, ask the question, get the reply. Instead, now you get an agent which can actually do stuff. It can write code, it can write DevOps tickets, it can do things that you don't want to do. So that is the agents and why it's important to use agents. Now, yes, you get these tools. Now, again, when it comes to working with agents, there are these agent executors. Basically, you need to manage the interactions between the LLM and tool. I will get into that when we get to code. Again, lots of benefits. Now, there are different kinds of agents, of course, aligned to different use cases. There's these zero-shot reactive agents, basically with no prior knowledge. It's supposed to give you like a completed result. There's a conversational agents, again, specialized chatbots, and MRKL. I do not know what this acronym means, so please don't ask me. Basically, these are agents that can structure and plan out a series of steps. We will get a bit into that. So there are two basic, let's say, approaches to resolving a task using agents. I'm actually using LLMs. So you can augment an LLM with tools. So as I mentioned, you can give an agent tools. But when it comes to just the LLM, like sometimes you don't need an agent. Sometimes you just need an LLM that can actually know, hey, what day is it today? So you can, using LangChain, you can create a parser script which will take your input and it will parse it in such a way that the LLM can send it to a bunch of tools that you provided. Basically, you give it the prompt, hey, you have this tool. This is how the input for this tool looks like. Now, if it gets a request, that it can figure out that, hey, I can use this request to match to this tool. It now knows that it can use that tool and it knows how to use that tool. So by giving all of these examples and writing these tools for an LLM, you can actually create a pretty powerful machine. But the issue here is that these tend to be pretty specialized, and they're specialized to the tools that you provide to the LLM. Now, we were working on something more generic, which would fall into this like LLM-driven task automation, where, again, you do have a parser, you do have tools, but here we have this agent executor as well, which will figure out the different tools to use. It will plan all of this out, and depending on the response it gets from its tools, it's going to make another observation. It's going to stay for a moment and think, hey, did I actually do what was asked of me? And it will get into this loop where it is parsing this observation and sending it back to itself until it produces a final satisfactory response. So this is what we were doing. You can see the the two different approaches. So this is the first one. This is the second one. So again, we chose this more generic approach where it repeats until done. And the good thing about this is when you just have the LLM that has access to tools, when you just have this like chain of requests, it's not really shown what it's doing. But here, with this generic approach, we can actually see what our LLM is doing. We can see its requests, responses. You can follow the reasoning a bit more, which was very important to us because calling an LLM costs money. And we really want to know why is it stuck in a loop and why is it charging us over and over again. So how did our application look like? Again, I'll show you the application. I'll show you the rest of the tools in a moment. So we created this OpenAPI agent. So we give this agent the OpenAPI specification, and we give it a bunch of tools. Here we have a human tool, which is you. So if it gets stuck somewhere, it's going to be like, hey, I don't know what I'm doing. Please help. And a variety of other tools that we created while we were working on this because it gets stuck. Sometimes we need to give it some help. The help we provided were these tools. So the heart of everything is, again, this API orchestrator. Now, if it figures out, hey, the request you gave me, I mean, I don't have to ask it to use an API. I can ask it, hey, do something else. But if I give it a question that involves using an API, it's going to generate this API controller agent. I mean, dynamically, in case it needs to do some like gets and posts. And this controller agent is going to use one of these request tools. So the tools that it knows how to use is it knows how to match the input to the tool's output, and it knows how to parse this output from the tool. And then it's going to like parse those and create these requests, and it's going to invoke them in chains until it gets some result. So as I said, LangChain turned out to be really, really simple to use. So we had this issue where, because we're doing event management, if I tell to the LLM, hey, create an event for tomorrow, call it, AP Summit, blah, 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 it does not understand what day is it tomorrow. So first thing it's going to tell me, hey, can you run this Python script for me and tell me what day it's going to say this today? So what we did, we copied the Python script here and give it to it as a tool. And we just give it a tag, hey, this is a tool that tells you what is today's date. Give it the name, give it the description. So now, when it gets to a situation where it needs to know today's date, if you say, hey, create something for tomorrow, but do it 2 days from now, it's going to know how to do that because it has this really, really simple function that tells it, hey, this is today. Also, I mentioned that we wanted to make it so that it can edit an API. It can create new entities in an API. I'll get to how it's doing that in a second. But you can also do that. I mean, what we did here, we created a script that can like expand the API. I'll actually show it live if it decides to be working today. And you'll see it literally creating a collection. And then if we want the agent to use this, we just give it a list of tools that it can use. So it's a very plug-and-play interface, really extremely simple, a lot simpler than I would have imagined, honestly. Now, since we are working with an API, we also use Strapi. What it is, it's a headless CMS. So basically, it's got this really useful admin interface that's going to be important in a moment. Basically, it allows you to click up a RESTful API. I mean, just open it. Hey, here's an entity. This property is date. This property is a number. You give it all this info, click create, and it generates the API. It hosts, a local development server. And it also creates the OpenAPI spec automatically and hosts it on itself. I will show you why that's important in a moment. And we use Streamlit. I'm not, is any one of us a front-end developer on the team? Okay, we do have some. But we didn't want to do front-end. So we have this tool called Streamlit. Basically, it's a Python library for quickly creating chatbots, web applications that communicate with LLMs, etc. It's really sped up development for us because it already provides us with an interface that we can use to interact with the LLM, with LangChain, etc. And the good thing about it, it's got hot reloading like from the start, so you don't have to like refresh all the time just because the LLM is not responding nicely to your prompt. So here's our project architecture. Now, this diagram is horrible. It's horrible because we asked the LLM to create this diagram, and we really didn't want to do any work. We want the LLM to do everything. And as I think everybody who's been doing presentations for this, everybody's been using ChatGPT and Open Diffusion, etc. And well, it's really good at creative images, like give me a surfing panda, blah blah blah. But it's really bad at creating these diagrams. But we wanted to explore its boundaries. I think we managed to find them. So how would the project architecture look like here? So the core of everything is, of course, the LLM. We use the Azure OpenAI. So the Streamlit is the front end. It allows us, it's got like a chat input window that we can use, and it gets the OpenAPI stack from Strapi. And then Streamlit is going to communicate with LangChain, is going to send it the OpenAPI stack. LangChain is going to learn all of that. So, and when we create a request, Streamlit is just going to send that a request over to Azure OpenAPI, and it's going to have those tools available, and it's going to dynamically call the tools it knows it has with appropriate requests and responses. So, time for a demo. I'm just going to open this here. Okay, has it died? No, it's still alive. Okay, let me just okay, we're going to try a few requests. I'm just very clumsy at the moment. Oh, good. So this is what Strapi looks like. These are all of our API entities. If somebody could just delete this, I mean, it's the most annoying thing. And here's how the actual application looks like. So as I mentioned, Strapi has given us the OpenAPI docs. So I'm just going to copy these here, enter the URL. Okay, I have clicked load. Okay, it's ready to use. So big breaths, boys. Let me just open up my prompts. I've written them here in notes, and okay, here we go down. So let's now try to create a new entry, a new event, and let's give it a prompt. So I'm going to tell it to create the second day of the Architecture Summit here for us. Okay, an event in Sarajevo on June 14th, titled AP Summit Day 2 at 7 p.m. So right now I'm giving it all of the data. It doesn't really have to use any tools. So it figured out, okay, it needs to use an API. What did it do? It has this input, and now you see this is the response it gets from the LLM, and it's planning out what it needs to do. Can this query be solved by API? Yes, it can. So it's going to generate later an API agent. Speak up. To the microphone or to you? To you, okay. I will try and project my voice in that direction. Ask the LLM to do it for you. I will have the LLM speak for me in a moment. So what it did do, it figured out the series of API calls it needs to create. However, you see this, it doesn't know what the date is because it didn't use any tools because we told it, which date is it, right? Which date to create it, but we did not specify, is it this year, next year? Because again, the training set for this LLM was finalized in 2023. So to it, it's still 2023, The Eurovision hasn't happened yet. And okay, so it's going to have this as the input, and here is the output. And it gives the extraction, it gives itself instructions what you should do with the output from the API, extract the ID and the name of the created event. API missing data payload in the request body. So, okay, there's an error. Why? Because it created a bad request. So now it's fixed its request. So it moved this data into a separate data key. And you see it actually, based on the response from the API itself, it managed to generate a valid reply. Now, if I go here to Content Manager, here are our events. And yeah, so this is day 1 that I tried this morning, and this is day 2. But again, notice it still thinks it's 2023. So, I mean, not great, not terrible. It's doing something. So let's see what are all the events. I mean, will it figure out which API endpoint to use? Get me all the events. API planner. So it used the API planner tool to plan out what does it have to do. Okay, it just needs to hit the get events endpoint. And did it do it? Okay, it's done. And error. Handled could not parse the LLM. And so it got this successful output, but it had an issue parsing it out. So it's still got some issues here. One thing that we wanted really to try, okay, let's try something. Let's see, does it know what day it is today? So as I mentioned, we created different tools for it to use. So create a new event for tomorrow. So call it drinks at Kucha. Drinks at Kucha. At 7 p.m. Now, what did I specify tomorrow? Because I wanted to see, will it use the appropriate tools? Okay, generated this. So what did it do? You see, get today date. So because it doesn't know what's the date, right now it looked into the list of tools we gave it, and it found this tool that can get today's date. So it knows now today is 2024, 13th of June. So now when it creates the request, it's going to be, the correct time, the correct date. It's going to have a validation error. I'm not sure if this due to the OpenAPI spec not being precisely generated, or maybe it's shortening something. I'll get into that in a moment. But let's see what it's doing. Okay, it managed to finally create drinks at Kucha on tomorrow's date. Let's give it a refresh. But okay, so this now let's give it something complicated. So as I mentioned, we wanted to check how good it is at doing complex tasks. Now, a more complex task for me would be, okay, you have an API. I want you to expand this API. I want you to give me a new entity in the API. So let's think of something. Create a new entity collection titled, what shall we say? Car, and give it appropriate properties. So I'm not gonna give it any details. Just try this. So let's see, will it manage to do what we've been desperately wanting it to do? Now, while this is working, take note, there are no cars here. There's nothing related to cars in the API. So let me just try and click back, if I may. Okay, so is it doing anything? Okay, so it's calling this tool called create new collection. Now you cannot see it on your screen, but I can see it on my screen, and now you can as well. So has anybody heard of Rabbit, the little AI device? So it turns out that these guys took like $30 million of investor money by automating a lot of things using LLMs. What they did, for example, they created this language execution model, which turned out to just be a bunch of Playwright scripts. Playwright is a UI automation library, for those who don't know. You can use it to automate websites. Now, so they managed to like get access to Spotify without being a partner by just creating a bunch of scripts that interact with Spotify and an LLM which can use those scripts. So we did the exact same thing because you cannot. There's like Strapi doesn't allow you to create a new entity collection, like a new endpoint, just using API calls. Because I mean, I think that would be a stupid functionality to have. An API that grows depending on the API call. So what we did, we just created a Playwright script and told it, hey, here are the possible inputs. Here's like all the parameters that we expect. You can use this if you ever run into a situation where the API doesn't have an entity that you need. So now I told it, hey, create this new collection. It figured out it can use this tool. It gave it appropriate properties. I'd say make, model, year, color, price, and it created it successfully. Now, if I refresh this here, boom, we've got car here. Now we could have asked, maybe can you like also create new cars? I think it really would have done that correctly. So it's definitely capable of doing things that are a little bit more complex. So we were really happy that it managed to do that. And now I've talked enough. We're going to let the LLM talk for itself. Okay, now I'm talking again. So, I mean, we used LLMs quite a bit during this entire process. And I think we really learned as a team a lot about them. Now, they're really good at being creative. They will give you a reply that's like to get, but they can be unpredictable. So I ran these exact same examples a couple of times for all of this, and it would sometimes get stuck like on the same thing that I typed in now. It would like try and get all of the events. It would say, hey, I'm trying to use this tool, but the tool isn't valid. And it's the exact same tool it's used the entire time, this get request tool. So there is certainly an element of unpredictability there. Now, why is that? So all of these inputs and outputs, all of them go to the LLM. And we send all of this to the LLM. And the bigger the payload, the more things kind of get lost while the LLM is processing it. And we also, you get priced per token. So let me just go back a few slides. I think we've got like some examples here. No. So here, for example, for this very, very simple request, to create an event where we've given it all of the parameters it needs, it used 8,874 tokens, 9 requests, and to do this, it cost us 30 cents. Like for a demo application, okay, I'm not paying for it. Yes, but I mean, to use this in production, it would really, really be problematic. So we have used these reducers that take all of these prompts. They kind of remove some of the things that would be confusing to the LLM. They try and make it smaller. But I mean, we are talking here about API specifications, and API specs are pretty big documents. I mean, pretty worthy. I mean, we can try and make them smaller, but it's still an issue. Yeah, its creative suggestions can be either efficient or innovative, which is really good.
You should go for pay-as-you-go service.
We should post our own LLM. That's definitely the way. So the thing is, we try to use LLMs with APIs. LLMs, creative APIs, constraint. And that is an issue we encounter right here also, because we gave it the OpenAPI spec and it still made a bad request. Because it got all of the data, but it interpreted it a bit creatively. So I mean, there's only one way to make a valid API request. More ways, but we won't get into that. But they're all well defined. It's a protocol, and that's our issue. That the LLM wasn't really that good at following a protocol. It was good at being creative, but we don't want the LLM to write poetry and paint. We want to do that while it does our jobs. So yeah, the deviation from the protocol did cause errors, as you guys saw. So aligning the API and the LLM to match, not that. So the biggest obstacle we encountered definitely was optimizing prompts. So the one that I gave, like create a new API entity, actually a new entity collection. I had to write entity collection. If I write a new API entity, what it always tells me, hey, I don't do that. That's not my job. Like I am just here to communicate with APIs. I don't make APIs. So I mean, if I just change that one word, then it works. So having correct, rigid prompts is a must. So you guys did not see this, but in the code, I mean, oh my God, I'm gonna have to drag stuff across the screen again. Bear with me, please. Up. Yeah. But okay, now this is just prompts. I mean, you need to give it a bunch of prompts so that it can know what it's supposed to do. And you see, for the API planner, I mean, to create the agent, you tell it, hey, you are a planner. And like these initial parts here are extremely important because this is what tells it, what it is. It's reason for existence. And here, it's very important to give examples to it so it can know, what it can do. And here, for example, even for the tools themselves, like even for like simple tool here for creating entities, I mean, you give it constraints like, what should be the value of this, the value of that, what is the type that you can use? I gave it these types because I was too lazy to make the playwright script work with numbers. So it's you really have to point it to what it needs to do, and you need to use very precise language because the prompting is everything in this case. So again, yeah, poor prompts lead to really inaccurate outputs. I mean, prompt design, really big thing. I mean, you really need to take some time playing around with the prompts to learn what works, what doesn't. I mean, everybody I know told us, hey, mess around with temperature. So what is the temperature? When you work in an LLM, you can tell it, be creative, which is you increase the temperature, or don't be creative, which is set the temperature to 0. Now, if you have something like that, what we have for the documentation, the API assistant, temperature is 0. Why? Because it's got a knowledge base. We don't want it to be creative. We want it to tell us where is stuff here. And here, the temperature was 0 the entire time, but still it would get creative, which we do not want it to do. Trade-offs, yeah, I mean, long detailed prompts result in higher token counts. So even doing something simple is going to cost you 30 cents. And high token counts can impact API interaction. So there are limits to how many tokens you can send, and there's also limits depending on which LLM you're using, like how many tokens per minute can you use. So if it's like a high use situation, I mean, you're basically blocked from making something that's more high frequency. So to make it good, you need to optimize the fonts for brevity and clarity, and that is the most essential part, I believe, when working with any LLM-based application. So now I will open up, and thank you, but now I will open up the floor. So now I will open up the floor for questions for myself and, again, the other 4 guys who have worked on this with me.
Leaving, you're not answering questions.
No. Andrew,
very good presentation.
Thank you.
It's the highest quality, very interesting. Quick question on the second last point there. When you say high token counts can impact API interactions, what does the Strapi API have to do with 10,000 tokens? Does it consume tokens?
So for the LLM, we need to send it the entire API stack for it to understand. So the bigger the API, the more tokens you need to send it for it to have an understanding of it. So that's really a big issue here.
The input tokens.
Huh?
The input tokens.
Yes.
The prompt tokens.
Yes, the prompt tokens.
Could you create fine-tuned models that understand those APIs and advanced?
Yes, there are actually already some projects that we discovered while working on this that literally do that exact thing. They take public APIs and they create LLMs that are fine-tuned to use those APIs.
When looking at a good API itself, it's quite dynamic.
Yeah, that's the issue. I mean, the changes are a bit difficult to consistently use the LLM for it. Lights in my face. Okay, if there are no more questions.
I do have one. How tempted were you to make exceptions? Right, you did a couple of scenarios. Your main scenario is event management. How tempted were you to make it work by just hard coding something for that particular case?
Oh, extremely. I mean, the way we started everything, I mean, you always first want to make it work, and then you want to make it actually work, this thing where it's creating a new API endpoint. Initially, it was just hard coded, give me books, but it took some time because it's a learning process. I mean, even all of the tools that you saw, we created the tools when the LLM would run into an issue, that you wouldn't have that issue later. So yeah, it was very tempting to just, record everything, let the nice lady sing with this beautiful presenter voice. But yeah, I mean, it's my big issue with LLMs. It's a black box. It's really not that easy. Even when you see the input and output prompts, it's not really easy to figure out, what it's thinking and what it's going to do next. So that the debugging is there. Yes, Andre?
You have an AI that can take this whole presentation, turn it into a good Medium article or something. So
Yeah.
that, I really think this is we interesting to see how you guys, I'm going to take the whole thing.
Wow. It took, we've been working we started on this 2 months ago, right?
March, let us know if we're full time.
Not full
Oh, I
time.
have to redo it. I don't want to take.
To redo it.
Now?
No, it wouldn't. Maybe
a
week, definitely.
Yeah, that's be interesting to see how you just work through the process of this, what you use for the tooling stuff. But yeah, that is very good.
Yeah, I think we could definitely make a blog post from this. Where is Noura? You were probably going to suggest this right after I said thank you. You were going hey, can we do it? Yeah. Yes, I know it.
Make sure that it adds bin.
What? A bin.
Collection without bin.
The bin, yes. The LLM doesn't know a lot about it. But I think the problem is, so when I was doing this, this playwright script that clicks on everything, if you choose number, then there's another thing you have to click. I didn't account for that. So this morning, I tried to add some numbers, and I was like, yeah, you cannot do that anymore. Use strings everywhere. So I'm guessing maybe because it knew it cannot use numbers, it skipped the thing.
You don't use content to create a model to the API. And it's free.
Wow, great. We didn't know that. We chose Strapi. I'm not sure why, but it's been a long process. We have learned a lot, really.
Would have been an interesting surprise.
Because it wasn't exactly. It's just JavaScript.
Yeah, we've definitely learned a lot on working with this. So again, once we get an idea.
I just would like to give the comment, so maybe you can help us, the rest of us who are not super technical anymore, or we are not super technical, to understand what's going on here. So I would like to say, many years ago, in 90s, when I started with Carol, so we didn't have graphical user interface as operating system. We were using DOS, and at that time, so we are using Clipper version Summer 87. And that's how we were making application and making the money. And so how it's working at that time. So if I wanted to, I was more on the front end, and Errol, of course, was the back end. And so we had the library where he was creating all functions and procedures that I would call, from my side. And then later with graphical interface, so it means anything that we wanted to have, we have to make it. So later with graphical interface with Microsoft and all better tools, so Microsoft and the other who, depending on tool, they would do that for us. So we would call, but still you will need to know, what to call, what you need to send. Majority of us are technical, so you know what I'm talking about. But actually, what's happening now, and I also would like to pick up, when I stop, so because I'm not so technical anymore. So we now have the code that's creating code. So we have the interface that, programs call programs for that interface. So we came kind of like holy grail programming. So we are taking jobs from ourselves. But thanks to all of this, we're going to be capable to make greater things. As we discovered in the last, from November 2022, many great things have happened. And it makes me really happy. I think that we're still going to be valuable and necessary, because I'm pretty sure for the people who are not super technical, it's still have no idea what you're talking about, right? But this is how I see that happening. So maybe you can just spend a couple more minutes to the people who are not super technical to explain what's going on here.
So I mentioned agents. So basically, all of these AIs, they're not very smart. The only thing they want to do is give you a reply that you will be like, yeah, I like what you told me. So agents are these AIs that have been given the ability to use different tools, to use different programs to write code. So why is that important? Because I have an example. There's this guy from Croatia. He wrote this, I think it's called Pilot GPT project. And in it, he defined a bunch of different agents. And he said, hey, we have a project management agent. We have a business analyst agent, a QA agent, a software architect agent, a software developer agent. And I mean, if you run his application, it's open source. You just need Python and ChatGPT subscription. And you give him a description of what you want these agents to make. It's going to like ask you further questions, going to do the job that somebody from an IT company that you're hiring will do. It's going to talk to you through this entire process, and then magic happens. The agents, they start working. They start coding your program. They start writing files on your system. And what's also very important, they start running those files. So basically, instead of having a bunch of developers working on that, now you have got a server somewhere in California with some knowledge in it that's like telling your machine like what to write to create a new program. So that is why these, all this hype about these agents. And really using agents is extremely important because I think we've all noticed that just speaking to a raw LLM is fun. You can chat through it. But once you give this LLM a personality, once you give them a role, it really constrains them and focuses them to use only a part of their knowledge so that they can like talk to different LLMs and they can collaborate in a network, in a chain, and really resolve tasks that you give it. Now, granted, there are constraints, tokens, like the price, how big the requests are. And, sometimes it lies. There's a saying in statistics, all models are wrong, but some are useful. Now, these LLMs, they do make mistakes, but they're still useful. Even when they make mistakes, you can come in, you can fix those things. So it's really, really, really a big deal. I mean, I use this what do I call it, Pilot GPT. I mean, I asked it, can you make me a workout planning app? And it in like 35 minutes, it created this React Native application for me that it was an ugly application with some architectural issues, but, it did what I asked it to do. So really, this is the future. So instead of having like 5 junior developers who I'm like preventing from going home late at night, we have LLMs doing the same.
Thank God they still need tokens, right?
Yes, it's
I just had one comment and then a question.
of course.
The comment is, please be careful with what you share. The information you just shared is shush. The question is, you talked about optimizing prompts.
Yes.
And I'm interested if you encountered anything like how constraintable, that's the word, are the prompts. Meaning, if you take your application, start a kind of conversation that goes way beyond your prompt that you set to the agent that it's a planner, planning events and dealing with that kind of thing. Can you start talking about weather with it and then go completely off track and make it confused?
Yes.
So the prompt doesn't really.
They do get confused. I mean, as we mentioned, short, precise prompts are what you need to get good results. And if you start dribbling the LLM, it will get confused. It will stop. It will say, "I don't understand the input. Can you please clarify?" That is definitely a big issue. Now, one thing when it comes to these prompts is that there are a bunch of LLM cheat sheets that you can find online that basically give you an entire list of keywords that you might use that will allow you to, like, the temperature thing, for example. That's basically a command line prompt that you send to the LLM that tells it, don't be creative, like give me straight answers. But I know there are additional prompts like that where you can like tell it, like how should it format the response, etc. Things like that. Now I'm not sure if I go off topic, but
keeping it on
keep it focused.
Keep it focused.
Yes.
So if you take your application and just ask, put in something like,
Let's try it.
What's the capital of South Africa?
Let's try South Sudan.
No need, I got the answer.
And it's going to give me the correct response, because when I tell it, do this, it's not like thinking by itself. It is ChatGPT.
But do you think you can make it see?
As I mentioned, you're not talking to the LLM, you're talking to the agent. And when we started, like when I was showing you these prompts here, you are a planner that plans a sequence of API calls. I mean, if I wasn't talking to this agent, it would go off topic. But as I said, we use agents because they constrain the knowledge of this so that it can stay specific, so that it wouldn't start, giving me some geography answers.
Yeah.
Yes.
But it's a generic approach. You saw that we uploaded documentation. So we upload some kind of documentation also. We believe that the data people can understand and reply. It's not an event management. We use it as example, but actually in prompts it doesn't say anything about events. It only learn about events when you upload documentation.
Because here, I mean, all we have is this is APIs.
Another application that deals with the weather. For example, if you upload it weather.com, I don't know, open API spec, then it will start responding to weather, whatever question you have about weather.
I mean, we can also
It's constrained, but it's constrained now because it uses this prompt and plus open API spec. So we constrained it with the open API spec, so it reads that and it only knows about get event, post event. Doesn't know about what is the data.
I mean,
say tokens by minifying your APIs.
even though we minify the APIs, because I think we use that reducer that does that already.
Basically reduce open API specs in order, to clean it up and make it as small as possible, but still keep like endpoints, the requests, the information about the payload it needs. I think we even remove like bad requests that it can return just, okay, this is the response to 100 that you're going to treat as a bad response. So we do have that, but still, like, I mean, the endpoint documentation we expose is pretty min. Like the only API, I think we have only a few APIs, but giving, for example, a more complex open API specs to this, it will cost money.
Yeah.
So optimization is definitely needed. Just a clarification.
Adnan, yes, for all of those who are picking up ideas, like what we did when we were building the Snap GPT platform, or accelerator that we use internally, we realized that we don't need to feed the whole OpenAI spec to LLM. We just need parameters, and we need types, and we need description of what those parameters are. So basically, we use classical computer science program, to parse out, because the open API specs are large, but they're structured. So you can extract what you want, and then we pass to LLMs just our version of it.
Yeah.
And then we map it back. When it gives us a call, we map it back to the real thing. So we save a lot of time.
This is what we did as well.
Yeah, and we got that built in. Because I mean, I think we all run into the same issues here, so it's a pretty pretty common issues. Yes, let's go.
Yeah, API to popular line with website.
What?
Popular line with website.
No, there is not. As I said, yeah, it's difficult to find one. Yes, there is.
So I'm sure you mentioned it, but I missed it. Which LLM do you use at the end?
Open API, ChatGPT.
Open which
Or is it 4.0?
3.5 at the beginning.
Yeah.
And we switched to model 4, then 4.0 once it came available. And then we switched to the Azure deployed one, which is back to 4.
Yeah.
And did you notice any difference between how these behave?
Yes, I mean, I did, at least from going from 3.5 to 4.
Yeah, that was a big.
It is you can see the difference.
Yeah, I mean, 4 is pretty good. I mean, I didn't notice too much between 4 and 4.0, but maybe it's due to maybe I didn't prompt it enough. I mean, given dribble nicely.
And if you have to compare, like when you were testing these last couple of days, making final drafts, how often does it get the thing right, and how often does it fail?
It gets tired. I mean, I don't know. Literally, this morning, I'm in the office. I start everything from scratch. I gave it the exact same examples I gave it here, and it ends up in a loop. Doesn't no idea why. Just it sees it's got like the tools. Like there's a requests get tool, and it says requests get is not a valid tool. Available tools are, and then a list, and the first tool in the list is requests get. So I'm not really sure. Like it's.
You didn't give it the coffee. So that's
After I had a coffee, both of us were much better.
So let's ask you, so what's the impact of temperature? So depending 0 or higher, so any kind of difference?
I mean, we kept it at 0. I didn't know that we increased it at all at the beginning.
We did a few tests with 0.7, 0. But we honestly, we knew, hey, we want you to be very focused on what you need to do. Don't get creative. Don't make stuff up. But it would, at the beginning, it was like, okay, location would be most of the time online. But even though we gave it, hey, we are planning an event in Sarajevo. And for the most of the time, it would get time wrong. So we knew we want you to be very, very specific at the task at hand that you need to do. So that's why we kept it at 0 almost all the time. We did play around with it. We didn't saw any benefits with the higher temperature. That's why we scaled it down to 0 almost.
How high did you go? And what's the difference? Let's say, not maybe just in this example, but something else that you did. So can you notice the difference between 1 and 10, or how high did you go?
I think I tested it out with the default one on the OpenAI playground itself. It's, I believe, 0.7. And it was trying really hard to satisfy the prompt that I gave. And it would invent certain things up, like a location or a time, and it would fulfill it. It would create something, but that wasn't what I was asking you to do. So that's the highest I at least tested. I don't know.
For the reference, Errol told me that's the highest is 1. So
I think it all depends on what you want to do, or what you want it to do. Because if we're doing something very concise, like making an API call and understanding how to use an API, that is quite concise, and we do not need to be creative. But if we write an essay, then okay, maybe a bit of curve.
Yeah, I mean, exactly like that. If you're building an app that writes children's books, what's that one? Have it be creative, you know? But if it's supposed to follow a precise set of steps, it should be 0, but yeah. I think the temperature is a lot more useful if you're using it to create images. So I know I played around with open diffusion like a long time ago, but I did notice that the temperature is more impactful.
What's called temperature?
No idea.
I don't know why it's called temperature because it gives you kind of like its level of creativity, right? So
Yeah, no idea what it shows.
hallucination.
Yeah, it's what it shows.
It comes from the process. It's an old like machine learning term called simulated annealing. It comes from the process when people like smiths used to make swords, and if it was more hot, it was more malleable. And they took that process, applied it to some old machine learning models where if you got stuck in some kind of local maximum, we wanted to find some global maximum, some like optimal solution. Then if the temperature was hot, we could then go to some other point of a solution and potentially find like some bigger maximum or some bigger peak. So the greater the temperature was, the more you're able to jump to like a different part of some optimal solution. So that process is called simulated annealing. And then later, OpenAI took that concept, they just put it in temperature. So if you have a predicting your next token, you're going to have some probability that's like the most likely token that's going to come next. If temperature is 0, you're just going to predict the most likely token. But maybe if it's a little bit higher, you're going to predict something that's less likely just because.
Yeah, it makes sense. Thank you for the educated part.
They teach their son, Berkeley graduate.
Anything else? Can I go get a bottle of water?